Good morning, student. In last lecture, we already discussed some properties. Then today's also we discuss some properties. Properties number 4, cos theta is equal to cos theta, right? Then we use the hyperbolic function cos z is equal to, what is the hyperbolic function? Cos z is equal to e raised to z plus e raised to minus z divided by 2. This is the hyperbolic function, right? Then here putting z is equal to theta, right? Then above equation becomes, काय होईल वरचं इक्वेशन? That cos, here not only cos, this is the cos hyperbolic, then cos theta is equal to, e raised to theta plus e raised to minus theta divided by 2, right? Then here we adjust some terms like that cos theta is equal to e raised to minus I theta, right, plus e raised to I theta. Why this arrangement? Because we know I square is equal to minus 1, right? Then we use this and we arrange this equation, okay? Then final that e raised to this means that cos theta, LHS side, cos theta is equal to, this means cos I theta, right? Here is also in property there cos theta is equal to cos I theta, right? Here this, and hence proof. Very simple. इथे जस्ट आपण हायपरबोलिक फंक्शन कॉस थीटा कॉस झेड इज इक्वल टू यूज केलं आहे आणि तिथे पुट केलं झेड इज इक्वल टू थीटा, देन कॉस थीटा इज इक्वल टू ई रेस टू थीटा प्लस ई रेस टू minus theta, then cos theta. Here we arrange some terms that minus I into I theta, that means minus as it is I square means minus 1 minus again plus, that means theta, no change here, and this is the proof. Okay, next one, next property, cos square z minus sin square z is equal to 1, right? Then here we use the two equations. Which two? That hyperbolic function, using hyperbolic function which hyperbolic function? Sinh z is equal to e raised to z minus e raised to minus z divided by 2, and cos z is equal to e raised to z plus e raised to minus z divided by 2, right? Then using these two hyperbolic functions and squaring both sides, that means squaring and adding squaring and subtracting of that two hyperbolic function, that means cos square z minus sin square z is equal to, in first bracket, e raised to z plus e raised to minus z divided by 2 minus e raised to z minus e raised to minus z divided by 2. Okay. That means here e raised to z means e raised to twice z, right? Multiplication means addition. We know this e raised to z into e raised to z means e raised to twice z. Okay, we know this using here, this term using here, plus e raised to z, e raised to z स्क्वेअरिंग केली तरी चालेल. इथे ए रेस टू मायनस ते स्क्वेअर आहे, राईट. दॅट मीन्स ए रेस टू ट्वाइस झेड प्लस ए रेस टू मायनस ट्वाइस झेड प्लस 2 minus e raised to minus, sorry here, e raised to twice z minus e raised to minus twice z plus 2. ब्रॅकेट स्क्वेअर स्प्लिट करून घेतलं, डिवायडेड बाय 4, राईट. इथे जस्ट आपण हा फॉर्म्युला यूज केला बघा. ए रेस टू झेड प्लस ए रेस टू मायनस झेड होल स्क्वेअर इज इक्वल टू ए रेस टू ट्वाइस झेड प्लस ए रेस टू मायनस ट्वाइस झेड प्लस ट्वाइस ए रेस टू झेड e raised to minus z, e raised to z, e raised to minus z, that means e raised to 0, and e raised to 0 means 1. That means e raised to twice z plus e raised to minus twice z plus that 2. Because here e raised to z into e raised to minus z is equal to e raised to 0 and is equal to 1. Here we use this. Then after that here this get cancelled, this get cancelled, 2 2s are 4 divided by 4. That means in here that cos square z minus sin square z is equal to 1, and hence proof. And we prove this property very simple here. In this property we use the hyperbolic function sin z is equal to and cos z is equal to, right? Then we squaring and subtracting from above two hyperbolic functions. Then cos square z minus sin square z is equal to a raised to this one, and this bracket we solve using this formula, and automatically this one. Then after this 4 get cancelled, and finally we prove that cos square z minus sin square z is equal to 1. Okay, got it? Okay, 6 number property, sin square theta plus cos square theta is equal to 1. Okay, we prove this property. The trigonometric function, using trigonometric function sin theta is equal to e raised to I theta minus e raised to minus I theta divided by 2i, and cos theta is equal to e raised to I theta plus e raised to minus I theta divided by 2, right? Then using that trigonometric function, here squaring and adding of that two trigonometric function, that means sin square theta plus cos square theta is equal to is equal to this one, e raised to I theta minus e raised to minus I theta divided by 2 whole square plus e raised to I theta plus e raised to minus I theta divided by 2, right? That means here we using this one. In last property also we use this. That means this bracket means e raised to 2I theta plus e raised to minus 2I theta minus 2 divided by minus 4, right? Plus e raised to 2I theta plus e raised to minus 2I theta plus 2 divided by 4, right? Then that sin square theta plus cos square theta is equal to this, okay, is equal to e raised to this minus sign in here. That means minus e raised to 2I theta plus 2 minus e raised to 2I theta plus e raised to 2I theta plus e raised to minus 2I theta plus 2 divided by 4. That means in here, see here, this get cancel, this get cancel, and this means 4 divided by 4 is equal to 1. That means cos sin square theta plus cos square theta is equal to 1, and hence proof. Very simple property this. Here we use this trigonometric function sin theta is equal to this one, cos theta is equal to this one. We squaring and adding of that two trigonometric functions, sin square theta plus cos square theta, then these two bracket, then we solve these two brackets, right? Then simple, and finally we prove this sin square theta plus cos square theta is equal to 1. Okay, in here missing that I, right? And we know I, 2I square means why that minus sign, this I, 2I, that means 4I square, and I square is equal to minus 1, that means minus 4. Got it? This minus sign how to take here. Okay, okay, got it? 7 number property, sin 2 theta is equal to 2 sin theta cos theta. Okay, here we take the RHS side first. 2 sin theta cos theta is equal to 2 as it is sin theta, that trigonometric function. Here we use the trigonometric function. Sin theta is equal to e raised to I theta minus e raised to minus I theta divided by 2I, right? And cos theta means e raised to I theta plus e raised to minus I theta divided by 2. Okay, here we take the right hand side and we use the trigonometric functions, that sin theta and cos theta means this one. Okay, then that 2 as it is in bracket, e raised to I theta, e raised to I theta means e raised to 2I theta a raised to I theta, a raised to plus a raised to minus I theta get 0 means 1 minus a raised to this and this a raised to minus 2 I theta, right, divided by 4 2I into 2, that 2 get cancelled. That means here a raised to I theta, a raised to I 2 theta minus a raised to I minus I 2 theta divided by 2I, right? That means 2 sine theta cos theta is equal to, this means sine 2 theta, and hence prove this. Very simple property this also. Okay, in that equation, in that property, we take this RHS side here. Okay, and we use that sine theta. That sine theta means a raised to I theta minus e raised to minus I theta divided by 2I, and cos theta means a raised to I theta plus a raised to minus I theta divided by 2. Okay, then this, then after solving this we got this, and this means sine 2 theta. We take here and we finally prove this property. 2 sine theta cos theta is equal to sine 2 theta. Last property of this chapter, 8 number property, cos 2 theta is equal to cos square theta minus sine square theta. Okay, we take here RHS side, cos square theta minus sine square theta is equal to, we use the hyperbolic function. Cos theta means a raised to I theta plus a raised to minus I theta divided by 2 bracket square minus a raised to I theta, hyperbolic function sin theta means a raised to I theta minus a raised to minus I theta divided by 2I bracket square, right? Then we solve this. We know this, how to solve this bracket. A raised to 2I theta plus a raised to minus 2I theta plus 2 divided by 4 minus sign as it is, a raised to 2I theta plus a raised to minus 2I theta minus 2 divided by 4 2I, its square is a 4I square. I square means again minus 1, that means minus 4 here. Then we combine this, all these, then this get cancelled, this get cancelled, a raised to 2I theta, a raised to 2I theta. Okay, that minus sign, that means again this a raised to I as it is 2 theta plus a raised to minus 2 theta divided by 2. That means cos square theta minus sin square theta is equal to, this means cos 2 theta, and hence proof. Very simple this property also. Here we take the RHS of this property and we use here trigonometric functions. Sin theta, cos theta means this one, sin theta means this one. We split this bracket, then after that, after splitting, here a raised to 2I theta plus a raised to minus 2I theta minus a raised to 2I theta plus plus again minus a raised to minus 2I theta, right? That means here a raised to 2I theta minus plus a raised to 2I theta, that means okay. And after this we prove this property. After this, some mistake here, sorry for that. 2I theta plus e raised to minus 2I theta plus 2 plus that minus, we arrange this minus sign here, that means e raised to 2I theta plus e raised to minus 2I theta minus 2 here divided by 4. That means this get cancelled, this all are 2 times, then 2 times e raised to 2I theta plus e raised to minus 2I theta, right, divided by 4. 2 to the 4, that means e raised to 2I theta plus e raised to minus 2I theta divided by 2, and this means cos 2 theta. And finally cos square theta minus sin square theta is equal to cos 2 theta, right? Here we discuss some properties of this complex number. Very simple here. 2 to the here 2 times this and 2 times this, that means 2 common, and here that 2 to the 4, the 2, and this means cos 2 theta. And we prove this property. Okay, in this chapter we discuss the total 8 properties in last and today's lecture. You must remember all these property and its proof. Many times in exam that type questions will be asking, prove that this okay. Here we stop. Thank you.